Welcome back to AP Statistics. Still not affiliated with the College Board. This is Dr. Kling. Now we're going to talk about, within the normal distribution, the problem of converting natural units to percentiles. So natural units are the units that something's measured in. The example I'm going to work with is rainfall in October. So every October we measure the amount of rain, and I'm going to assume that the mean rainfall is 3 inches, and the standard deviation is 0.8 inches. I'm making that up. And so the natural unit is inches. And when we ask a question about percentiles, it might be, what is the probability of getting less than 1.0 inches? Or if we get 4.5 inches, what percentile are we in? That is, what percentage of months of October will we see less than or equal to 4.5 inches? So if we're to draw this on the normal curve, do one of my wonderful drawings here, and we'll put, so what we're showing on the vertical axis is sort of probability, and on the horizontal axis we could have the inches of rainfall, and if this is my mean, there's 3.0. And what the probabilities that we're measuring, we can only measure along intervals. So we can measure probabilities along intervals. Like the probability of getting 3.000000 inches of rain in October there's actually no probability that will occur. We can only talk about the probability that let's say 2.90 is less than x, maybe less than or equal to x, is less than or equal to 3.10. We could talk about that. We can talk about an interval, but we cannot really talk about the probability of getting an exact number. So how do we... Let me draw this one more time and ask the question. That's an even worse drawing, but so be it. We have along the x-axis we have the natural units, which I'll call x. In this case it's inches. We have percentiles, which we can't, now I can't see the whole graph, but percentiles. So the mean at 3.0 inches is also the 50th percentile. And if we go out one standard deviation, I said the standard deviation was 0.8 inches, so we have 3.8. And I think one standard deviation takes us, I think, about to the 84th percentile. So what that means is that 84% of the time we will see less than or equal to 3.8 inches of rain. So that's inches, the natural units, and that's percentiles. And the question is, how do we get from inches to percentiles? And the traditional way of doing that, we first converted the inches to standard deviations. We measured the standard deviations, and then we looked up in a normal distribution table, a standard normal table like this one, which allows you to convert the standard deviations to percentiles. The tradition was we had two steps. We did step 1, convert natural units to standard deviations. That's called converting x to z. And then step 2 was look up in a table. Now nowadays you don't have to do these two steps. You can do it pretty much in one step on a calculator or a computer program, but I like to teach something that's pretty close to the old two-step method, but instead of looking up in a table, we use a function on the calculator to do the looking up. So let's draw it again. Maybe I'll draw it a little smaller. Okay, and so we have three ways of measuring along the x-axis. We have x, natural units, inches. We have z, which is standard deviations. We count how many standard deviations away. And then finally we have percentiles. And I'm going to do the two-step process for going from inches to percentiles. So let's take our example of what was our first question. What's the probability of getting less than 1.0 inches? Okay, so the probability of getting less than 1.0 inches, we take the 1.0, we use first the z transformation, x minus mu over sigma. Okay, x is our 1.0 inches. Mu we said was 3. Sigma we said was 0.8. So z is equal to 1 minus 3 over 0.8 equals negative 2 over 0.8 equals negative 2.5, I believe. Okay. And now we're going to do the looking up in the table part. And looking up in the table means going to second distributions, and we take norm CDF from a negative of a very big number. Even 10 is a very big number because there's essentially no probability of getting out 10 standard deviations. So from negative 10 to negative 2.5, and our answer is, well, here I set it up on a spreadsheet. I put in, hang on, I call the left-hand value of z, z1, the right-hand value of z, z2, and I take norm CDF from z1 to z2. So we were taking it from negative 10 to negative 2.5, and our answer was 0.0062. So that's our answer, 0.000062. And that's the probability that we'll get less than 1 inch of rain. And then what was our second question? Our second question was, if we get 4.5 inches of rain, what's the percentile? So again, we do that in two steps. So z is equal to 4.5, that's our x, minus 3.0 over 0.8. Equals 1.5 over 0.8, and again we're interested in the percentage of time that we get less than or equal to the 4.5 inches, so we do norm CDF from, again, we'll take negative 10, which is a big enough number, to 1.5 over 0.8, and we'll see what we get. Hold on a second. We'll put in equals 1.5 over 0.8. That was what we had before, and now we have our answer of 0.9696, or we'll just call that 0.97. So we'll put that back here. So that says that 97% of the time we'll get 4.5 inches of rain or less. So one thing I want to finish up with is you always want to sketch a normal curve and figure out what it is the question asks. So if the question asks how much is less than or equal to a number, then we're doing norm CDF from -10, a big number, to Z1. If we were asking to the right, then we would be doing norm CDF from your Z value. Actually, I should call that Z2 up there. From -10 to Z2. If we were going to the right, then we would do norm CDF from the Z value that we get to a big number like 10. So to the right, we take from Z1 to 10. In fact, we're taking it from Z1 to infinity. Here we're taking it from -infinity to Z2. And then finally, if we're taking the probability of getting in between two numbers, let's say from here to here, then we just do norm CDF from Z1 to Z2. Next time we'll talk about going from percentiles back to natural units.